So there are different strategies to solve these non-right triangles. This one here, this is one way to do it, is to draw this perpendicular in here. And this seemed to work out because we were able to solve these right triangles independently. We had enough parts of this triangle here on the right hand side, which I'll highlight, which allowed us to draw that perpendicular. Now there are other options in that we could have drawn our perpendicular down here. Okay, and sometimes this gives us the triangle that we want. Okay, so that triangle there, if we drew a perpendicular on the outside of that triangle, that's another way we could have solved this. So in this example here, this is the option that we're going to choose. Okay, the problem if we draw the perpendicular the same way we did before is we split that angle, and although we have two angles here, we would know that that's 55 degrees. Okay, the problem that we end up with is that this triangle has no side length that's known. And if we take a look at this triangle up here, same thing. We know that angle would be 55 degrees as well. Okay, and we don't have a triangle that can be solved here. Now this one here, we can actually use some symmetry. If we recognize that there's symmetry, we should be able to figure out that this is in fact an isosceles triangle. Okay, so this is a special one. So there's our perpendicular. We draw it straight through there. It's 55 degrees. Now we have an isosceles triangle. So this is a little bit easier problem to solve. Okay, so this is 55 degrees here, 55 degrees here. Anytime we see symmetry, we want to be able to use that symmetry. So these allow us then to split up that 19 into 9.5 along here, 9.5 along here. Okay, so this is a nice way to be able to split this up. And the only reason we can do this is because it's symmetrical. Okay, if it's not symmetrical, we don't have this ability to split up that side of 19 into known parts. So once we have that, we can solve these triangles. In fact, these triangles are exactly the same. So x is equal to y. So I'm going to use the 35 degrees, and I'm going to use adjacent side to 35 and hypotenuse. Adjacent hypotenuse is ka, or cosine. So adjacent to hypotenuse is going to be 9.5 to y, and that's cosine of 35 degrees. Okay, because the side I'm using is adjacent to 35. I could have used opposite to 55, but that would involve using the sine ratio. Okay, so solving this, I'm going to punch that into my calculator. I get 0.819. I can solve for y algebraically. Again, just remember that we could solve this as a proportion, 0.819 to 1. We're going to solve that algebraically, so I get y is equal to 9.5 divided by 0.819. Okay, so that's going to end up being 9.5, about 11.597, so I'm going to round that to 11.60. Okay, so y is 11.60. Because of the symmetry of this, we know that this angle works out to be 35 degrees. Okay, and the x length is exactly the same as y. Okay, this is an isosceles triangle.